To do is solve for x, but it's going to be something you haven't seen in a different situation. So it's 2 raised to the power of 3x plus 1, and that equals 2 to the power of 2x plus 5. Now, because they have the same base of 2, we can just eliminate those bases and look at this as basically an Algebra 1 problem. And then solve that for x. Second one. 2 to the 3x plus 1 again. But this time it's going to be equal to 4 raised to the x plus 3. Now I want to wrap that x plus 3 up, and you'll see why in a second. I wanted to do these table of values, so notice that 4 can be rewritten as 2 squared. 4 can be rewritten as 2 squared, and I'm going to want to do that. So I'm going to copy this base down with 2, base 2, raised to the 3x plus 1 power. And 4 can be rewritten as 2 squared. But notice, I have that x plus 3 behind it. So I have to bring that x plus 3 down. Now I find myself in this earlier situation where I have the same base of 2. So I can get rid of those 2's. And now I'm going to solve this for x. 3x plus 1 equals 2x plus 6. 2 to the 5x plus 2 equals 8 to the x plus 10. Now I'm going to want to rewrite that x plus 10 in parentheses because I'm going to change this 8 to a base of 2. And notice, 8 can be rewritten as 2 to the 3rd power. So this is going to be 2 to the 5x plus 2 equals 2 cubed. But I have to bring down the x plus 10 in back of the 3 from the 2 cubed. Now, once I have it in that form, notice the 2's are the same base again. I can eliminate the same base, and I can rewrite this as 5x plus 2 equals 3x plus 30. Three to the 5x plus 2 equals 9 to the 2x plus 6. And again, I'm going to rewrite this as a power of 3. So I'm going to wrap that 2x plus 6 up. And I think we all know that 3 squared is 9. That 3 squared is 9. That 9 can be rewritten as 3 squared. So I'm going to rewrite it. That's going to give me 3 to the 5x plus 2 equals 3 squared. But now I have to remember to bring down the 2x plus 6 inside those parentheses. And once I have it in that form, I have common bases, so I can eliminate those 3's. And I'm just going to solve the equation 5x plus 2 equals 4x plus 12. Is a little bit different. Now it's a log base 7 of 3x plus 2 equals log base 7 of 2x plus 9. And because they're both log base 7, they're common logs, I can eliminate those. And then this is going to give me 3x plus 2 is equal to 2x plus 9.
Subtract 2x.
Number 6, log base 2 of 6x minus 1 is equal to log base 2 of 5x plus 7. Again, they're both written with a common log of a log base 2, so I can eliminate those. And then that's just going to give me 6x minus 1 equals 5x plus 7. Now number 7 is where it gets a little tricky. I have 2 to the x is equal to just 10. I cannot write 10 as a power of 2. 2 to the second equals 4, 2 to the third equals 8, and then 2 to the fourth equals 16. So there's somewhere in here, so there's going to be some decimal like 3.5, 3.3. 2 to the 3.3 might equal 10. So I'm going to rewrite this in logarithmic form. So I'm going to write the word log, and then a base, and then an argument, and that equals an answer. The base is 2. The argument is 10, and the answer is going to be the exponent. Remember my little story where the log leg kicks the 2 and the 2 kicks out over underneath the x and raises it up, and you get 10 equals 2 to the x. So this is going in the opposite direction. Now, once I'm here, I'm going to use technology. I'm going to want to use the Casio. So once I'm there, I'm going to use the tech. And the button is this log base button right there. If I hit that button, it gives me the log base. And now I just have to type in the 2, right arrow, and put in a 10, hit equals, and I get this big long decimal. And notice, it was actually x equals 3.3219. We usually go out to 4 decimal places. And I can check that. So if I do 2 to that power, so 2 to the power of 3.219, 3.219, I'd have never guessed that. And it gets me, 3.32. And there it is. So close to 10. So close to 10. Notice it was 3.3219, 2 to the 3.3219. And if I round that to 4, that 1, 2, 3, 4. If I round it to 3, it'll give me 10. Same scenario. This time, 7 to what power equals 52? Well, I know that 7 squared is 49. So this is going to be a little bit bigger than 2. So I'm going to rewrite it in log base form. So I need the base, I need the argument, and it's going to equal some answer. And this time the base is that 7. The argument is 52. And the exponent is the answer. So I'm going to type in log base 7 of 52 and see what I get. Again, my guess is probably pretty good. It's going to be like 2.2. Log base 7, right arrow, 52, 2.0305, 2.0305. My guess is a little too high. So that's what x equals. Five to the x equals 120. Well, I know that 5 cubed equals 125. So this is going to be less than 3. That there x has to be less than 3. So I'm going to rewrite it in log base format. Log base of some number of some argument equals some x. So the base is 5. The argument is 120. And the answer is going to be the exponent of x. We're going to hit the log base button. Type in the 5, right arrow, the 120, and again, it's going to be less than 3. 2.97 equals 2.9746. Log base of 5 of x minus 2 equals 2. Now this one, instead of leaving it in logarithmic form, I want to rewrite it in exponential form. And here it is, that log leg kicks that 5, the 5 goes over there, pushes up to 2, that's going to give me 5 squared, and then the log leg runs away. So that's going to give me x minus 2 equals 5 squared. Add 2, and that's going to give me x equals.
Oops. X equals 27. I messed up, not 25.
Of 2x minus 1 equals 3. That log leg is going to kick that 3. That 3 is going to fly over and push up that 3. 3 cubed is 27. The log leg runs away, and that's going to give me 2x minus 1 equals 27. Number 12. Log of 2x minus 4 equals 2. So this is a tricky one. Notice there's nothing down here. There's nothing down there. And I think we've already discussed this. If there's nothing down there, it's a hidden 10 as the base. So the log leg is going to kick that 10. And the 10 is going to push up to 2. And 10 squared, that's going to equal 100. So the 2x minus 4 comes down after the log leg runs away. And I want to solve this.
What makes this difficult is that they have different bases, so I can't use any of this table maneuvers. I just have to go at it using properties of logarithms. So the move is to try to rip the exponent out.
In order to rip the exponent out, you have to ln both sides. When you put an ln in front of that base, it rips that exponent, x minus 1, out in front. So that entire exponent is going to go out in front of the ln. And it's going to give me a new situation that looks like this. X minus 1 ln of 2 equals x plus 2 times ln of 3. I have to continue. I'm going to distribute the ln2 across the x minus 1. So that's going to give me x ln2 minus 1 ln2 equals x ln3 plus 2 ln3. I'm going to continue. I want to group the x's on one side. So I'm going to minus x ln3 from both sides. And I'm going to add the 1 ln2 to both sides. That's going to give me x ln2 minus x ln3 equals ln2 plus 2 ln3. Notice these each have an x in front of it. I'm going to factor out the x. Muchos x. So that's going to give me x times ln2 minus ln3 equals ln2 plus 2 ln3. I'm going to divide both sides by ln2 minus ln3. So my final answer is x equals ln2 plus 2 ln3 over ln2 minus ln3. Bar ln2, close the parentheses, plus 2 ln3, close the parentheses, down arrow, ln2, close the parentheses, minus ln3, close the parentheses. Hit equals. I'm going to take this out to 4 decimal places. Negative 7.1285.